Okay, so we finished up with blood pressure being much lower in the pulmonary circuit than the systemic circuit, where we had about 25/10 millimeters of mercury there. Okay, control of blood pressure short term. This can be really short, like over the matter of seconds. Here we got vasodilation and vasoconstriction, so the blood vessels themselves are going to change diameter and regulate blood flow. Or blood pressure, sorry, and flow too. But so vasodilation, now let me make sure I don't confuse myself. We're talking about pressure. Vasodilation, making the vessel bigger around, will decrease blood pressure. So right here, right, decrease blood pressure. So vasodilation will decrease blood pressure. Vasoconstriction will increase blood pressure. All right, so vasoconstriction, increase blood pressure. All right, neural control of blood vessel diameter. Chief brain center is the ... So anything that's involuntary, so we don't have to think about dilating and constricting our blood vessels. But remember, anything that's going to be involuntary, like that, the medulla's got its hand in that cookie jar. So medulla. And next chapter after that, every time there's something involuntary, when we ask what's in charge, remember, it's always the medulla for involuntary stuff. Just like it's always the cortex, cerebral cortex, if it's voluntary stuff. Okay, so brain monitors pressure in several places by you guys don't have to write anything here, but it says baroreceptors. Actually we do need to write some. Here, go. These are modified mechanoreceptors. I spelled it wrong. Oh, yep, I did. Thanks. Modified mechanoreceptors. Remember the same receptor type that's like involved in touch and hearing, but they're detecting the amount of like stretch in the blood vessel wall. So as the pressure starts to get high in there, it stretches the wall out a little bit more, and they can pick that up. But so here on a location example, there are two different big places where we monitor, and pick one of the two. Let me find this picture here. This is showing you the whole reflexive set. It's just some picture I found online. So medulla's in charge. It's monitoring all this. And we've got, and that's probably kind of hard to see, but there's the heart, and you can see these nerves coming down. But here we got aorta baroreceptor. In the, for one, you can say the aorta, but to be a little more specific, that part right there, you guys remember the name of that part? Remember the arch, the aortic arch? So write that down for one of them right here. So right there, location example, aortic arch. And if you want to do the other one, cool. Wait, I lost my thing. There we go. Here it says the carotid sinus. If you guys want, you can put common carotid artery right there. The carotid sinus it's the place where the common carotid forks into the internal and external. Anyway, right there we've got another group too. So if you want to put carotid sinus or common carotid or just carotid arteries in general, that'd be okay too. Okay. Other stuff the medulla keeps track of besides the pressure in the aortic arch and the carotid sinus. So it also checks out chemical composition. So we got here, it says example, and it's kind of already I've written it down, but here we got oxygen and pH. Like in response to changes in blood oxygen, it'll tweak blood pressure. Like it kind of depends on where you're at, but like hypoxia low oxygen will kick in vasoconstriction sometime. Will jack up pressure and increase blood flow. But you don't have to write anything here. I was going to put an example, pH or oxygen or carbon dioxide or something like that, but we're kind of covered there, so we'll just leave that off. All right, hormonal control. Move this over. Hormonal control of blood vessel diameter, epinephrine and norepinephrine. For this one, let's write. Well, it depends on what blood vessels we're talking about. So for humans, remember the whole fight or flight response thing, to some places it causes vasodilation, and to some places it's going to cause vasoconstriction. Remember, again, fight or flight, the whole sympathetic thing. If you're fleeing or fighting or preparing to do so, oops, where do I want to put it? It's kind of hard to do this. There we go. Anyway, in there somewhere. You want to increase blood flow. I'm just going to type it to skeletal muscle, because that's what you're going to use to punch, kick, and run away. So you make those blood vessels bigger around. Vasodilation. Did I mess that up? Spell check. Thanks. Vasodilation. That's going to increase the blood flow. But, again, no magic tricks in physiology, so if you want to send in more blood to the skeletal muscle, you're pulling it out of somewhere. So you get vasoconstriction to blood vessels that go to the viscera. Remember, your guts, like the kidneys, stuff like that. Okay. ADH. Remember, we did ADH in the hormone chapter. Remember what it stood for? If you don't, write down that. Antidiuretic hormone. But, then, remember, it conserves body water. So if you're starting to dehydrate, it tells the kidneys to put less water in your urine and hold on to it. But it's got another name. It's also called, again, I forgot the book, but this is also known as vasopressin. If your book calls it arginine vasopressin, that's pretty much the same stuff. If there's some difference, I'm not real sure what it is anyway. But so vasopressin, which tells you what it does in terms of blood vessel diameter. Vasopressin, it squeezes blood vessels, presses blood vessels, so it's a vasoconstrictor. So over here, right, vasoconstriction, because we're doing control of blood vessel diameter. I think in that role, like all the time we use it to regulate our body water content. I think more as a vasoconstrictor. That's like if you're something's going pretty wrong, like you're bleeding pretty severely or something like that. I think you'll get really high levels of ADH, and then it'll increase blood pressure. You know, like if you're bleeding super severely and your blood pressure was dropping, you know, like you're bleeding out, or something like that. Okay, nitric oxide. Nitric oxide's not a hormone, but it's a chemical messenger in the body. Nitric oxide is a vasodilator, so it causes vasodilation. Remember, that's how Viagra works. It increases blood flow. But Viagra doesn't just work down there. It works everywhere you got blood vessels. Remember, it was originally Viagra's its brand name, but that drug was originally a drug for hypertension, for high blood pressure. So also, if you increase the diameter of blood vessels, remember, it drops the pressure there. All right, long-term control of blood pressure says the kidneys play a major role in terms of how they filter and hormones. Here, where it says when blood pressure is high, this is by how you filter and process blood to make urine. The long story short is this, and we're just going to do the short story. But when blood pressure is high, you have more water is going to be lost from the body in urine. They'll put more water in your pee. So remember, your blood pressure is starting to get a little bit high. More water goes out in urine. It's kind of like letting a little bit of air out of your car tires. It's going to drop your tire pressure. It just drops water pressure. And then down here, when blood pressure is low, just write vice versa. Your body will start to conserve more water so you don't lose as much to pee. Because your pressure's already getting low, you don't want it to get lower. Let more air out of the tires, so to speak. Okay, so more water loss from the body in urine here, and then down here, just write vice versa. It's the opposite. All right, here's our hormones. The renin-angiotensin mechanism works like this. It's kind of a complicated domino effect, but it says when arterial blood pressure is low, when it drops, the kidneys release. Now, here's the renin part of the name. Just write renin there. I was going to copy and paste it. Cut. Paste. Renin. Renin's it's an enzyme that doesn't end in ACE, but it's an enzyme that leads to, here, just read this. This leads to the conversion of a plasma protein into angiotensin II. Like, Well, where's angiotensin 1? It's in there. We're skipping that step. We're just going to the end of it. But hey, guys, for y'all that are nursing folks, you'll hear about a class of drugs called, if you haven't already, called ACE inhibitors, which are used for hypertension and stuff like that. They act here, so in the conversion of this angiotensin 2. Actually, I don't remember exactly where it is, but it's somewhere in between the production of this and the end result of this. It helps reduce that. Okay, so here's what angiotensin 2 does once we finally get it made. So this substance does two things. One, it stimulates aldosterone release from the blank glands. Remember what glands make aldosterone? You don't? And over here, well, they're paired. Adrenal. So over here, right, adrenal glands. It's one of the steroids that come out of the adrenal glands. Remember what it does? No. This. Conserves sodium, so it tells the kidneys to put less sodium in your urine. And if your body holds on to sodium, your body holds on to water, because water follows sodium. Remember that whole osmosis thing. And if you increase the water, that increases blood pressure. Because remember, just like car tires again, if you put more air in your car tires, it's going to increase the air pressure. Putting more water in your circulatory system is going to increase blood pressure. Remember why we released this in the first place? Because our blood pressure was dropping. And then so here's one mechanism to raise it back up. So again, if an ACE inhibitor is being used as a hypertensive drug, it's going to help block this effect and lower blood pressure. All right, and here's another way it does the same thing. It lowers blood pressure, or causes vasoconstriction, raises blood pressure. And then here, just write the same thing. Not this part, but vasoconstriction, as we said before, increases blood pressure. So write that down here. Vasoconstriction, you can clamp down those blood vessels, and that increases blood pressure. And that's as far as we got to go. I'll see you in class after break for notes.